So hopefully by now you guys have watched the first video for this class, and you can see, if you have watched it, that there is a lot of room for interpretation in some of these questions that we come up with, whether or not the study is a inferential study or whether it's a descriptive study. The key is you have to be able to defend your position very clearly and very precisely when you explain why you choose the study that you did. There'll be some cases where the type of study is very obvious as to what kind it is, and it's going to be really hard to argue the point against that. So just make sure that you are very clear and concise in your language when you're answering these questions, and just be sure to be very careful when you're addressing the population when given a sample. I know today in class we talked about, for example, the question clearly said 1,000 U.S. adults. That was the sample size. So we understand what the sample is. It was the 1,000 U.S. adults. The population would be the U.S. adults, not U.S. children, not U.S. teenagers. It's pretty much anybody over the age of 18 or older. That's the population that we were looking at with that particular question. Another one, I believe it talked about 59% of Americans or something like that, but it said that 59% came from a sample of Americans. So it did not address the specific number of Americans that they sampled, but it does clearly say, though, that there was a 59% rate amongst Americans that they sampled that yielded the data that they had. So the sample size would be the Americans that they interviewed. The population would be Americans, and it would be all Americans. Or actually, I'm sorry, I believe that question did say between 18 and 29 years old. So the sample size is the 18 to 29-year-old Americans that they sampled. The population is all 18 to 29-year-old Americans. So when you give an answer for a population, please make sure you are very specific about that population. Make sure you indicate all the certain criteria that the study has put on the group that they wish to study. It's not always going to be everybody that we want to look at. So what we're going to look at right now is what's called simple random sampling. And we're going to look at a lot of different ways that you can gather data. There's a couple of different methods of sampling that we will look at over the course of the next couple of days. So you can read through here about some of the ways that you might want to look at a sample of data, because the example that I list right here, it's talking about a consumer group that wants information about the gas mileage of a particular make of car. Well, we're not going to go out and sample the gas mileage information of every single make or every single car of that make. That would just be unreasonable. It'd be a very costly study to conduct. It would not be very reasonable to send out people to try to find every single, let's say, Toyota Corolla from 1999. We wouldn't be able to find every single 1999 Toyota Corolla and get that gas mileage information from every single car. So we do want to find a sample of those cars, and we want to make sure that sample comes from different driving conditions, different regions of the country, driven by different groups of people. One of the stereotypes is elderly people do seem to drive more slowly than more younger people. So, if you drive slower, you're probably going to improve your gas mileage as opposed to somebody who's hammering down on the gas pedal and doing 95 on the parkway. They're going to be burning up a lot more gas a lot more quickly. So a lot of different factors come into play. The second paragraph, you don't have to reinvent the wheel. If a study's already been conducted, use that information. There's no sense in redoing it unless you find some fault with the way the study has been conducted. So the things that we're going to look at here: census, sampling, and experimentation. Two methods other than a census. So a census is you're talking to everybody. The United States Census that's conducted every 10 years, they send out that information to every U.S. household in the country. They don't just get random samples, they send it to everyone. And that's why it's called a census, is because they're looking at everybody, the entire population. So the alternatives to a census are sampling and experimentation. For the majority of this class, we're really just going to be talking about sampling. We're not going to look a whole lot at experimentation, but we will touch on it from time to time just to get an idea of where experimentation would come into play. So if we're going to address sampling, we have to understand, or we have to look at, what is the most effective way to generate a sample of the population that we wish to study. And there's a couple of different options to that. And there's also things you have to be careful about. I mentioned right here that using the average weight of a sample of professional football players is not very effective to make an inference about the average weight of every adult male in the United States. The game that I was watching when I typed this up, they had mentioned at one point that the average weight of the defensive line, I think for the Ravens maybe, was 350 pounds. That's not effective in saying, okay, using that information to make a blanket statement about all the males in the United States. You cannot say the average weight of an American male is 350 pounds. It's just not true. And you're using a non-representative group to indicate that. It also would not be reasonable to estimate the median income of Perry County residents by only sampling the incomes of doctors at ARH Hospital. Doctors obviously are going to make a considerable bit more than, say, somebody who's working at Tractor Supply, a teacher for that matter. And so the doctors would not be an effective group to sample to represent an entire population of Perry County. Here we talk about elections again. We're talking about the presidential election in 1936. And they conducted an opinion poll. It was the election at this time was between Franklin D. Roosevelt and Alfred Landon, and based on the results of the survey, they predicted that there would be an easy win for Alfred Landon. However, Roosevelt won that election by a landslide as one of the largest victories in presidential history. And when they looked at why that happened, what was the issue that created such a glaring error in predicting the election, the way they conducted the opinion poll was they used the telephone. And so when they did this, the sample was obtained from people who owned a car or had a telephone. And in 1936, people who owned cars and had telephones were more well-to-do. They had more money than most other people. At that time, telephones were not common in every household like they are now. So more wealthy people tended to vote more Republican. And the response rate was very low. Only 25, or actually less than 25% of people responded to the survey. And so that meant that there was a disproportionate number of Republican supporters responding to the survey. And this skewed their information, and they didn't realize it until it was already too late. And the election results came in, and they found that they were horribly, horribly wrong. So we have a couple of types of sampling that we want to look at initially. We have simple random sampling, and with simple random sampling, it's just a procedure for which each possible sample of a given size is equally likely to be the one obtained. Simple random sample is a sample obtained by simple random sampling. So those two definitions tie together. One is the sample group, one is the method. When we say a sampling procedure for which each possible sample of a given size is equally likely to be the one obtained, we're talking about if I took, say, let's just say for the sake of argument, there's 800 students at Perry Central, and I wanted to sample a group of 40 students. If I break the student body up into 20 clusters of 40, there is a 1 in 20 chance that one of those clusters of 40 will be selected. It's an even chance that one of those 40 will be selected. There's no skewed or bias to what group may or may not be selected. So simple random sampling with replacement is not very common. So what that means is if you take a group out and you study them and then you put them back in, and then there's a chance still yet that they might be selected again. That doesn't happen very often. The other one that we are going to see more commonly is a simple random sample without replacement. So once I take a group out, study that group through whatever means necessary, I don't put that group back into the entire population. If I want to continue the study, maybe I pull a different group out. So we're going to kind of break all that down. That's a lot to digest. We're going to break that down in a very easy to understand example. The top 5 state officials of Kentucky are the governor, lieutenant governor, secretary of state, attorney general, and the treasurer. The letters that you see next to each one of those titles are what we're going to use for this problem, rather than having to write out those titles every single time. So part A just says list the possible samples of 2 officials from this population of 5 officials. So we're going to list just in groups of 2. Every possible combination of 2 officials out of the 5 that we're given. So it's easiest to just start with the governor. So we have G, and then we compare the governor up with the lieutenant governor. We compare the governor up with the secretary of state. We compare the governor up with the attorney general. And we compare the governor up with the treasurer. So there's nobody else we can match the governor up to, so then we move down the line to the lieutenant governor. The lieutenant governor can be matched up to the secretary of state, can be matched with the attorney general, and can be matched with the treasurer. Again, we've exhausted all possibilities of combining the secretary or the lieutenant governor with anyone else, so we go on down to the secretary of state. The secretary of state can be matched up with the attorney general, and the secretary of state can be matched up with the treasurer. Once we've exhausted those possibilities, we go down to the attorney general, who can be paired up with the treasurer, and we have no other combinations that we can select from this particular pool of officials. So if we count these up, you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 total small sample groups of 2 from the population of these 5 state officials. A method for obtaining a simple random sample of 2 officials from this population: put their job titles on a slip of paper and drop it in a box and have somebody draw out 2 slips of paper. There's your sample. They may draw out the governor and lieutenant governor. They may draw out the secretary of state and the attorney general. But that's one way to generate a very small, simple random sample. When we're talking about larger populations, drawing things out of a box is not going to be effective. We're going to have to use other methods to come up with that. I don't know what's wrong with my dogs. If you can hear them, I apologize. So for part B, you can just simply say drawing names out of a hat, drawing them out of a box, whatever the case might be. But we're always going to select just 2 names to generate the sample. For part C, it says, for the sampling method described in part B, what are the chances that any particular sample of 2 officials will be the one selected? There's a reason we counted how many samples are generated by that group of 5, and we came up with 10 possible 2 official samples. So if we just reached in the box, drew a name out, maybe it's the governor. We reach in, we pull another one out, it may be the secretary of state. So that would be this particular sample right here, GS. That's the governor and the secretary of state. Out of the 10 possibilities, there is a 1 in 10 chance that we could draw any one of those 2 official combinations. You're going to see here for part D that if we expand the size of our sample, we're going to come up with some different figures. So for part A, if we did repeated part A with a sample size of 4, again, we'll start out by listing the governor. And since we're doing a sample size of 4, we need to list that official with 4 other officials. So the governor, the lieutenant governor, the secretary of state, and the attorney general. Then we can do governor, lieutenant governor, secretary of state, and the treasurer. So with the governor, lieutenant governor, and secretary of state, there's nobody else that we can combine with those. So maybe we skip now and we do the governor, Lieutenant Governor. We skipped the Secretary of State. We have the Attorney General and the Treasurer. We could also do the Governor, Secretary of State. We're skipping Lieutenant Governor now, and the Attorney General and the Treasurer. And we can get one more because we've combined everyone with the Governor. We've done all the possible combinations we could do with the Lieutenant Governor. We've done all the possible all the possible combinations of Governor and Lieutenant Governor. The last one would be the Lieutenant Governor, Secretary of State, Attorney General, and Treasurer. Again, this is one of those cases where, since the population is so small, the samples are so small, our response for Part B would still be the same. We could just put the names in a hat, draw them out, and we have created our sample size of 4. For Part C, repeating it for Part D here, for what sampling method described in Part B are the chances that any particular sample, in this case of 4 officials, will be selected? Well, I have 1, 2, 3, 4, 5. So there is a 1 in 5 chance that any one of those 4 sample groups would be selected if I just simply drew their names out of a hat. When we start moving on, drawing names out of a hat is not always effective, especially when you have large populations. So this is where we get into random number tables that make things a little bit easier. Sorry, I was interrupted. I'm trying to think where I was at. So I think I was talking about when we draw names out of a hat, that's okay for a small group. But what if we're talking about groups of, say, 100 people, 200 people, 1,000 people? You don't want to put 1,000 people's names in a hat and draw out 100 names and make that your sample. So there has to be a more effective way to do it. The first way we're going to look at it is called a random number table. And we're going to do that by example. So that's here with example 2. It says that teacher evaluations, they gained widespread use in the late 1960s and early 70s. Generally, professors would hand out evaluation forms a week or so before the final exam. Then students would fill those out, and they would have their results of the teacher evaluation. However, the problems that they had with that is on some days, less than 60% of registered students would attend class. Sometimes they would get their teacher evaluation and they would quickly rush through it because they knew that once that evaluation was done, they could leave class, and they might either just want to get out of class or they may want to get on to another class, whatever the case might be. Sometimes they just don't want to do them. So what they decided to do, a better method would be to just take a simple random sample of students and interview them individually. So if you sit down with them, you can get a better response from these students. So we have this hypothetical situation where one semester a professor wishes to sample the attitudes of the students taking college algebra at his school. He decided to interview 15 of the 728 students. So using a registration list on which the 728 students were numbered 1 through 728, he obtained a random sample of 15 students by randomly selecting 15 students between the numbers 1 and 728. So here's where we would not want to put 728 names in a hat and then draw 15 of them out. So a random number table will help us. And this random number table here we're going to use several times throughout this course, and actually I refer to it on a couple of your homework problems. So this is the number table you're going to use. So to select 15 random numbers between 1 and 728, we first pick a random number starting point, maybe closing our eyes and placing our finger on the table. Then, beginning with the 3 digits under the finger, we go down the table, da 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 da. You guys can read the rest of that. But the key here is, let's say that we want to pick our 15 students. All right, we're going to use random number table, and we want to find out what those students might be. So if I close my eyes and I put it here on the computer, I have landed on 523. I know that's a 5-digit number, but we're only interested up to 3 digits. So any number from 1 to 728 is what we're at. So 523, that's our first student that we're going to survey. Then we go down here, 978, that is not one of our numbers, so we can ignore it. 689, 410, 667, 707, 760 is not going to work, 986 isn't going to work, 836, 783, 547, 20, 34, 21, 412. So far we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students. So then what you do is you shift over, and now we go to the next three numbers. So we have 433. That falls within our values that we're looking at. Then we have 986, which we ignore, 119, 893. There's number 10, 58. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I need one more. 380. And then we just check these 15 numbers to make sure none of them are the same. If any of them were the same, then we would follow that process all over again and we'd keep going. But you can see what I did is I just picked, in this case I needed up to a 3-digit number. So I started at a 3-digit number, I went down the list, and then I started going back up the list. And when I got done with this row, or this column, I would start back down and look at another group of 3-digit numbers. And that's how this number table works. That's how a random number table works, at least. But there are other ways of generating these numbers, and they come up with Microsoft Excel or on our calculators. So I know a lot of you don't necessarily have one of these calculators at home, so Microsoft Excel will make this relatively painless to generate a random number table. And you can do that. I've got a lot of G's typed in here somehow. Let me just go back to our notes. You can see here on the left I have a random number table that I generated using Microsoft Excel. The method is really simple. So what I want to type in is equals RAND, which tells us it's going to be random, and then between, and in parentheses I want to put the numbers that I want to use. So I'm going from 1, 728. I hit enter and it puts 503 in that box. So I'm just going to highlight all the way down, drag that formula down to number 15, and there's my random number table for 15 students numbered 1 through 728. So Microsoft Excel will make this very simple. If I wanted any other number set, I could do rand between 1 and 5,987, and then I would just drag that down. Maybe I want 25 samples, and there's my 25 numbers that I would pick. So if I numbered everybody in the population using this 1 through 5,987, these are the ones I would pick for my sample for the study that I want to conduct. The last thing that I mentioned too is your calculators will do this as well, and you can see that on the screen here on the right, and that's again a very simple process. Let me pull up the calculator. You will go from the home screen, you're going to go right here to where it's list and spreadsheet. Click on that, and in this little equation box you will type in RANDINT, so it's random integer, and our starting number is 1, our ending number is 728, and then we put another comma, and this is where we tell the calculator how many numbers we want. So we want 15, and there is my random number table. Whoa, scroll down too fast. 15 students from the previous example and their registration numbers. So these are the 15 students I would select, I would interview them, and then I would have my sample for the study. I believe that is the end of this set of homework. Okay, that is. So there's your homework problems. You guys will see these when I hand you the notes in class. And again, like I said, if you have questions, please ask. I hope so far things aren't too difficult for you, and that you'll find some value in this class, especially when you see that it will definitely transfer and keep you from having to take another class at school. So I hope everybody has a great night, and I will talk to you in the morning.